Alright, here's the review for day 2 of the final exam practice for calculus. So we look at number 22. Find the limit as theta goes to 0 of 1 minus cosine theta over 2 sine squared theta. So again, we start, when we do limits, we always want to start by trying to directly substitute, but when we do that, sine squared of 0 is going to be 0, so it's undefined. So we got to find something else to do. So we know from trig that sine squared theta plus cosine squared theta is equal to 1. So that tells me that cosine squared theta, well, 1 minus cosine squared theta is equal to sine squared theta. And this, 1 minus cosine squared theta, is a difference of 2 squares. So that can be written as 1 minus cosine theta times 1 plus cosine theta, and that's still equal to the sine squared of theta. And that's going to be helpful because that means that I can turn this right here into that, and now I have factors, and it looks like now I can cancel out the factor on the top and the factor on the bottom. So if we rewrite this, the limit as theta goes to 0 of 1 minus cosine theta over 2 times 1 minus cosine theta times 1 plus cosine theta. And those are going to cancel now. And I'm left with the limit as theta goes to 0 of 1 over 2. Oops. Sorry, canceled the wrong thing a second ago. So let me just rewrite that. That was 1 minus cosine theta, 1 plus cosine theta, and we wanted to cancel the 1 minus cosine thetas. So I'm left with 1 over 2 times 1 plus cosine theta. Now we can directly substitute. That's 1 over 2 times 1 plus cosine of 0 is 1. So I get 1 over 2 times 2, which is 1/4, and that is my limit, 1/4. 23. If g of x is equal to sine of x, then there exists a number c in the interval pi halves to 3 pi halves. It satisfies the mean value theorem. Which of the following could be c? Well, the mean value theorem says take f of one end of your bound minus the other end of your bound divided by the bounds. That is just the slope of the secant. So f of 3 pi halves. So if I plug in 3 pi halves right here, I end up with sine of 3 pi fourths. And then if I plug in pi halves into that, I get the sine of pi fourths all over 3 pi halves minus pi halves is just pi. And that leaves me with sine of 3 pi halves is rad 2 over 2 minus pi fourths is also rad 2 over 2 all over pi. It gives me 0 over pi, which is just 0. So the slope of my secant line is 0. The mean value theorem says that we should be able to find if it's a continuous function, which it is, and it's differentiable, which it is, there should be some c value in between these two intervals such that the derivative is equal to the slope of the secant, which in this case is 0. So I'm going to find the derivative of sine of pi x, or of x over 2. So the derivative is going to be cosine of x over 2 times the 1/2 because of the chain rule. Leaves me with 1/2 cosine of x over 2. And now we're going to set that derivative equal to 0. So 0 equals 1/2 cosine of x over 2. Multiplied by the 1/2, it goes away. 0 is equal to the cosine of x over 2. Cosine of something is 0. Well, I know that cosine is 0 when we are at pi halves or 3 pi halves. So I set the inside x over 2 equal to pi halves and equal to 3 pi halves. And when I solve that, x equals pi or x equals 3 pi. Well, which one of those is inside my interval? Pi is in my interval that we were given. 24. The limit of the sine of 4 times x plus h minus the sine of 4x all over h is something that looks like the difference quotient, f of x plus h minus f of x all over h, which tells me this is how we do derivatives. So this must be a derivative, but it's the derivative of what function? Well, f of x is my function. There's my f of x function. So all I need to do is take the derivative of the sine of 4x, and I'm done. So the derivative of sine of 4x is going to be cosine of 4x times, using the chain rule, the derivative of 4x, which is just 4. So I'm left with 4 cosine of 4x, which is b. 25, find the absolute minimum value of the function. Absolute minimum, that's going to be the first derivative, equal to 0. So when I multiply this out, 1/4 times 4 is x cubed plus 3x squared minus 10x. I'm going to set this equal to 0. Then I'm going to go ahead and solve this by factoring out the x. And I'm going to factor this a little bit more. This looks like it's going to become x plus 5x minus 2. So when I solve this, I get x equals 0, -5, and +2. Those are my critical points. So now that I've got those critical points, I can apply the first derivative test, which we make the number line, -5, 0, +2. We're checking the derivative, the sign of the derivative in between each of those values. So I'm going to check like a -6. I'm going to check -1, +1, and then 3. And I'm going to check them in that x times x plus 5 times x minus 2, because it's going to be the easiest way to just multiply it in my head. We got -6 times, see, 6, -6 plus 5 is -1, and then -6 minus 2 is -8, so I've got 3 negatives, so that answer is negative. If I plug in a -1, I've got -1 times 4 times -3, that's 2 negatives, which is a positive. I'm going to check +1 now, so it's going to be 1 times 6 times -1 and back to a negative, and then I'm going to check a 3. So 3 times 8 times 1, that's back to positive. So I know I'm going to have a minimum when my slope goes from negative to positive, because we have a negative slope, we switch to a positive slope, switch to a negative slope, and then back to a positive slope. So I should have a minimum at either one of those two lowest points. So I need to check what happens at -5 and at +2. We don't know for sure just by looking at this which one is it. So we're going to check -5. We're going to check +2. +2, if we plug that in, we get 1/4 times 16. So that's 4 plus 8, that's 12. 12 minus 20 is -8. And f of -5 should give me 93.75 when I do some calculator math, and I get the answer A is my minimum at -93.75. 26, I apologize again, this problem should not be on there. That's for second semester for us. So the last one that we're going to do today because there's some problems with the word, there's some issues with the word problems as well. So we'll go ahead and stop here. The graph of y equals cosine of x is concave down on which of the following intervals? So concavity, we have to use the second derivative. So we are going to find y prime, which is negative sine of x. Then we're going to find y double prime, which is negative cosine of x. And we're going to set that negative cosine of x equal to 0. That means cosine of x equal to 0, so x is going to be equal to cosine is 0 at pi halves and 3 pi halves. So then we're going to apply, or we're going to look at the second derivative, pi halves, 3 pi halves, and we're going to check values. So something smaller than pi halves, I'm going to go with 0 is smaller than pi halves. Something between pi halves and 3 pi halves is pi, and something bigger than 3 pi halves, well, we're going to go with 2 pi. So I've got, if I plug in 0 into my derivative, second derivative, cosine of 0 is 1, we get negative 1, so it's negative. Cosine of pi is 0. I'm sorry, cosine of pi is 1, negative 1. So it's negative negative 1, which is positive 1. And then the negative cosine of 2 pi is the same as 0, so it's going to be back to negative 1. So we've got negative, positive, negative. Concavity, it's concave down. When I'm less than pi halves, it's also concave down when I'm greater than 3 pi halves, but I don't see those intervals on here. But I do know that 3 pi halves, if we think of the unit circle, so I know when I'm less than pi halves, so there's pi halves, there's 3 pi halves, there's pi, and 2 pi. Less than pi halves is coming back around this way on the unit circle. And then also when I'm greater than 3 pi halves, so I'm going this way on the unit circle. Well, I know that positive 3 pi halves is the same as negative pi halves. Those are the same value. So I can say that I am concave down anywhere between negative pi halves and positive pi halves. That's the entire right side of my unit circle. That is answer D. That's going to be it for day 2 review, because we're not going to go over the word problems. Like I said, there were some issues with them, so we will talk about those in class.